Hello everyone, we're going to do a real quick review of an introduction of valence electrons and what those actually are. So this is going to be super fast, and we're going to start out with a review. And that review is going to be on electron configurations. And we were learning about all of this last week when we were learning about 1s2, 2s2, and those kinds of things, right? So let's see if I put this in 1s2, 2s2, 2p6, blah, 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 blah. Remember? So we're going to be talking about that and using that here for the next few minutes. So here's the thing you need to know. Electron configurations can show us where all the electrons are located in an atom, and it can show us which electrons are available for use in chemical reactions. And that's very important because not all electrons, I want to write that right here, not all electrons are able to bond. Not all of them are. In fact, any electron that's locked up in a complete shell, and that shell is completely full, it's kind of like, I don't know, it's kind of like having a savings account, and then, you know, at first you can pull money out of your savings account, but then let's say that savings account, after it gets so much amount of money in it, then you have to move it to a retirement account or something. Well, once that happens, then you can't touch it. You can't touch it again until, you know, you're like an old lady or old man or something. So in that case, not all electrons are able to bond, just like not all money is able to be spent at any given period of time. So there's two main types of electrons, okay? There's the inner electrons, these guys, and these are not available, not bonding, okay? So the inner electrons are not bonding. We can't use those to bond with. And then we have these other ones. We'll do this in orange. These are valence electrons, and these are the bonding electrons, okay? So these are the bonding electrons. So which is better, to have a whole bunch of valence electrons or to have not very many valence electrons? Well, it just depends, right, on which atom you're talking about. So let's go look at what those are real fast. So we need, oh, wait a minute, there's your assignment and code for Flipgrid. Your code for Flipgrid to do your attendance today is valence electrons, just letting you know. By the way, for Flipgrid, what you're going to do is you're going to log in, you're going to do a 30-second video, and you're going to tell me, number one, you're going to tell me what your assignment is. So basically, you're going to look over Google Classroom and find out what your assignment is. You're going to tell me the code word, okay? And today, your code word is valence electrons. And number three, the thing that you're going to do for today is you're going to tell me your favorite, tea-giving food, okay? So what is your favorite Thanksgiving food? Mine is not. I don't like hardly any Thanksgiving food. Maybe mashed potatoes if I'm in the right mood, but generally I hate Thanksgiving food. Blech, I don't like it. So you tell me, what is your favorite Thanksgiving food? The code word, we've got that up here. Okay, and then your assignment, you're going to have to find that on Google Classroom. Okay, so back to this. Let's do electron configuration. So sodium, what is the electron configuration for sodium? Well, we know that sodium is atomic number 11, which means it has 11 electrons, right? Which means we're going to put them in electron configuration like this. 1s2, there's 2 electrons. 2s2, there's 4 electrons. 2p6, let's see, 6, 7, 8, 9, 10. That's 10 electrons. We only have 1 left. And it's going to go in the 3s1, okay? So this is the long form. Well, we also know that this whole thing right here, okay, is actually neon, isn't it? So I could put, if I do the electron configure or the noble gas configuration, I would put brackets neon, okay, 3s1. Okay, now the inner electrons, these guys, that's everything in here. Everything in the noble gas configuration. Those are considered inner electrons, and they can't be used. They can't be used, okay, for bonding. I'll put for bonding. My writing's kind of messy. For bonding. Then everything outside of that, and let's go ahead and make this a different color. Everything outside of that is considered an outer electron. Okay, that's the outer electrons, and these can bond. So you tell me right now, how many bonding electrons does sodium have? Well, let's see. How many electrons are here? Just this guy right here. So it has one bonding electron. And we call this bonding electron a valence electron. Okay? So that is a valence electron. One bonding electron. So let's do another one. By the way, if you're having trouble knowing how to do all of these, I put some links on the lecture guide. And also, if you will follow along in your lecture guide, you're going to see that you can fill that in exactly, because I'm giving you word for word the answers to that lecture guide right now. So let's see, let's do chlorine. Chlorine, we know, has 17 electrons. And I'm doing this without a periodic chart in front of me, but that's okay. I'm just trying to get through it fast. So what would that be in long form? Well, it's going to be 1s2, 2s2, 2p6, so there's 10 of them, 3s2, 3p, let's see, there's 10, 11, 12. How many do I need left? I'm going to have 7 here, right? 7, 8, 9, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I did it wrong. Hold on. 7, 8, 9. And then that's 19. That's too many. What did I do wrong? Oh no. Hold on. I know it's 3p7, or it's 2p7. That's what my problem is. Hold on. Having a brain fart, you guys. It's too early in the morning for me today. Okay, let's try this again. It's got 17 electrons. So that's going to be 1s2, 2s2. It's hard to do it without a periodic chart in front of me too. 3s2, 3p. It is 7, isn't it? 7. Yeah, that's it. 2p6. I forgot that. 2p6. So there's 10. And then here's 3p5. That's why. That's why. I'm like, what's going on? I'm thinking 7. It's 3p5. Come on. Come on, Bowman. Don't you know your chemistry or what? Apparently, I do not know my chemistry without a periodic chart in front of me. I'm so sorry. So it's 3p5. So, with that said, let's do the electron configuration in noble gas. So, we know that this is neon. Maybe. I'm doing it without a periodic chart. So I'm going to put brackets neon right here. There we go. And then we're going to end up with 3s2, 3p5. Okay? So which one, or which electrons are the inner electrons? Well, that's going to be all of these guys. Those are the inner electrons. And there will be no bonding with those. No bonds with those. They cannot be used. They're locked up in the trust fund, okay? The neon trust fund. But then we have, we'll do these in orange. The outer electrons. Well, which one are the outer electrons? That's going to be the 3p5 and the 3s2, okay? So that's going to be right here. So let's put that over here. How many bonding electrons does chlorine have? Well, it has 5 here, right? And it has 2 there. So it has 7 bonding electrons. can't spell. It has 7 bonding electrons. That means it has 7 valence electrons, okay? And that's the term we're looking for today, is valence electrons, the ones that can actually be used for bonding. Okay, let's do one more, and that's going to be for carbon. The electron configuration long form for carbon. Well, carbon it has 6 electrons. Okay, we know it has 6, so that's going to be 1s2, 2s2, 2p2. Okay. Well, we know that this is actually helium, right? So we could write that in noble gas configuration. This is going to be helium. And then 2s2, 2p2. Okay. Well, we know that these guys are the inner electrons, right? They can't be bonded. So there will be no bonding. I'll just put a big can't bond. Over here, what are the outer electrons? Well, let's change our color again. The outer electrons, okay, are going to be these guys. Those are the outer electrons. How many of them are there? Well, there's 2 of them in the P shell and there's 2 in the S shell. So that means we have 4. And what's the term that we're looking for? Valence electrons. Okay, so carbon has 4 valence electrons. It has 4 electrons that it can use to bond with other things. Okay, now here's some more stuff about valence electrons. Valence electrons are the electrons in the outer shell, which we just talked about, and they're electrons that are available to bond. There are a maximum of 8. This is why I was freaking out on that chlorine thing, but see, I wrote down 7 on that P7, and there's no such thing, right? It only goes up to P6, and that was throwing me off. That's why I was ending up with 9 valence electrons. So sorry about that, brain fart. But anyway, there are a maximum of 8 valence electrons. That's the max. Okay, so if someone says, oh yeah, there's 10 valence electrons in something, well, you know they're automatically wrong because there's only 8 max, okay? Valence electrons are easy to determine because they are related to each group on a set pattern. What are you talking about now, Ms. Bowman? There's a set pattern. Well, let's check out this next slide and you will see. Okay, everything in group 1 has 1 valence electron. Got it? Ha-ha! Everything in group 2 has 2. Let's see if I can write it. 2 valence electrons. This one has 1 valence electron. Over here, in group 3, guess what? 3 valence electrons. Are we catching on here? Noble gases have 8 valence electrons. And chlorine and all of the group 7, the halogens, they have 7 valence electrons. Everybody cool? Here's carbon. Carbon was in this group right here, and carbon, of course, has 4 valence electrons. The number of valence electrons corresponds to the group number. Ah, nice. Now what about these guys in the middle? What do they have? Well, here's what we're going to do right now. We're not even going to worry about them, okay? We are not going to worry about them because these guys, we're going to learn how to bond with them later, okay? So the metals, don't worry. Don't worry about, I can't spell, O-U-T, about valence electrons. They don't worry about them, okay? So don't even worry about the metals in the middle. We are worried about groups 1 and 2 and groups 3 through 8. Or well, I guess it would be groups 13 through 18 on the periodic chart. That's what you're worried about right now. Nothing else, okay? So the metals, don't worry about them. We're not even going to worry about their valence shells. And I'll never ask you what the valence electrons are for anything that's in the middle there, I promise. Okay, so if you're in group 2, guess what? You're going to have 2 valence electrons. If you're in group 7, you're going to have 7 valence electrons, and so on and so on. Got it? Okay, hey, what was the code word again? Do you remember? What was the code word? You're going to need it for when you take attendance on Flipgrid. Well, the code word, almost back there again, the code word is valence electrons. So you need to go to Flipgrid. If I can't spell, hold on. There's like a blank spot, I think, on my iPad there. So I'll do it over here. Flipgrid. You're going to record a 30-second video. By the way, your video will not be able to be seen by anyone except for me. And it's only for attendance purposes. I will be taking attendance with Flipgrid. Got it? So you have to make sure that you have your Flipgrid video recorded and submitted so that I can take attendance. If you don't do it, then I'm marking you absent. I'm marking you absent. What do you have to be considered present? You have to tell me your assignment. You have to tell me the code word. And you have to tell me your favorite Thanksgiving food. Got it? Okay, go do it. Get it done.